Some years ago, I delivered a talk at the IXDA Miami group after we launched Magic Leap 1 ONE Creators Edition. Feras was really just very interested in security and ethics in terms of AR, and we talked for quite a while. I am really excited to have Feras participate in the talk tonight because I feel like we can kind of continue our conversation around some of these issues. Anyways, without further ado, this is user data privacy in the metaverse. I'll give you a little bit of information in terms of my background. I spent some time at IBM doing a lot of AI-driven data visualizations, particularly with news data. This was in the era before fake news. At the time, we were trying to figure out what to do about news that wasn't as reliable. I worked for Magic Leap for about 4 years. My last title was lead interaction designer, and I worked on the user experience team for the platform. The more recent role I have is director of product design at Faceware. So we work on facial motion capture software and hardware. The applications are usually to drive an animated 3D character in a game or on a TV show or at an expo. I'll hand it off to Feras. Thanks.
Yeah, thanks, Tim. And I remember our conversation at that meetup several years ago. And it was a meetup just like this one, so I expect many people here have been friends for years and will continue to stay friends for many years. I did some of this background in my earlier intro. I think the only thing that might be interesting to people here is that I'm a corporate lawyer by training, and I guess just with that caveat, none of the stuff that Tim or I are going to talk about is legal advice. So get your own lawyer if you need, if you have questions about some of the legalities of what we're going to talk about. We'll get into some of sort of the regulatory space a little bit because I think it's interesting how that stuff interacts. But certainly this isn't legal advice. And I think the second piece here is I didn't touch on this earlier, Praveen, but I'm also a UM grad. That's where I got my law degree, and it's where I practiced when I started, and I'm really interested. Again, my background in games has only been as a player, not as a designer or anything more than that. But I think what was really cool at Magic Leap was that we got to interact with so many different groups, and so here was a person that had a traditional sort of privacy, security, corporate background at the intersection of games, and there's a couple folks here that have a healthcare focus. And so I think there's a really interesting conversation we can have about how games and training can be used in healthcare. And that's where I spent some time. So at Magic Leap, I was, as Tim said, I was on the product side. I was a product manager for security and privacy. And before that, I was our healthcare specialist on security. And so my background is extensively in the healthcare side and specifically on the enterprise security side, but we'll talk a lot about consumer today. So I'm really excited. Tim, thanks again for the invite and the opportunity to co-host. We kind of think this is going to be like Mystery Science Theater 2000 or 3000 style, where we'll go ahead and just kind of have a discussion together. So without further ado, go ahead, Tim. You can move on. Thanks.
Thanks for us. So the talk will be divided into two sections. The first section will cover the work that myself and Feras participated in at Magic Leap in different capacities. And I think this is interesting because it'll tie into the second half, which is kind of moving forward and looking more at the consumer use cases for XR technology in the future. So the terminology is always changing as we speak, but the Magic Leap, I think of it as a mixed reality headset. You might also call it an XR headset, extended reality, because it does encompass, it can encompass virtual reality, it can encompass augmented reality, it's all the above. And Apple has recently used the term SR for simulated reality. The idea being that you are able to look through a pair of glasses that project content into your eyes as if it were existing in space. The front of the glasses are loaded up with sensors, various cameras. I believe there are 4 different microphones. Correct me if I'm wrong, Chris. So it's basically a combination projector recorder as far as the wearable headset part. Also a light pack, which is computer processor, or I should say the central computer processor. And then there's a controller. There are different applications on the device. Here are four. The one on the top left is Avatar Chat. So this is a chat application that allows you to basically you can be on your kitchen table or out on your patio and have some friends over who are represented as 3D avatars. Each of the friends is also wearing a Magic Leap device. Their hand movement, their mouth movement, even their eye blinks are all controlled by sensors on the device, and obviously their voices carried through as well. The example in the top right is a screens application where a user, this is kind of one of the killer apps where you're in your living room and you want a TV that's 18 feet wide. Well, you can have one now. You open up your screens app, you put on HBO, and voila, you have it there. So that's definitely a popular app. Spotify in the bottom left, the third-party application for music listening. I think this one's interesting from, we'll get into the spatial aspects of the platform a bit here, but this is interesting because it allows you to put albums on your wall as if they were like memorabilia. And so to do that, it has to gain access to the planes, the mesh, so that it can place those objects. And then the bottom is a virtual keyboard, and the beam that's kind of that's extruding from along the bottom there at those floating keys is the 6 DOF ray cast from the control. So in this one, you're actually seeing it like I guess you might call it a first-person shooter style of a keyboard on our device. We're getting into privacy stuff, and my area at Magic Leap, the thing that I worked the most on before I left, related to the spatial aspect. Just to kind of give you background, and I'll just read this right off the slide, and the picture speaks 1,000 words too, but world features are 3D representations, also called point clouds, of the world around you, and serve as basic building blocks of a spatial map. World features can be used as reference to place and persist content, so you can come back to that content later at the same place. And world models add more detail to your spatial maps, including dense mesh data and planes, and the results are spatial maps that provide much more accurate representations of the world around you, enabling digital content to respond to the environment in a more natural way. And then finally, world understanding, what I'll be talking about next. It allows Magic Leap device to recognize some types of classes of objects in your environment, such as the ability to identify chair, poster, etc. We're going to go into the settings of the device and go to mapping, and we're going to show you how you would turn on object recognition. So the first thing you need to do is make sure world features is set to shared. And we're kind of scrolling around. Object recognition on the Magic Leap device is called world understanding, or it's rather bundled into, I guess, a larger category of object information called world understanding. And so once you do that on our platform, you see these floating labels show up. And there are currently 6 objects that are detected: chairs, screens, couches, pictures, and so forth. So you can see some of these labeled in actually in my home office. And then, yeah, you can walk around and kind of see how confident the system is in detecting these objects. What's kind of interesting about the initial deployment of object recognition on the device is that it is the data, in order for it to even run, it's fully public. So you have to set world features to shared. And so what that means is if I go in the same space as you do with a Magic Leap, your device will detect objects and share that data, and mine will do the opposite basically. And so I'll be able to see the objects that you detected, which is really interesting. When I was first working on this, I would be walking around the office and I would see objects that other people had labeled. And when we talk about the metaverse, that kind of gets into it in a really light way. This idea of like a shared digital space over the physical. Here's a look at the settings. This is actually an earlier version, a slightly earlier version. And you have privileges on the left where the user can grant access to object recognition or object data on a per app basis. And you have the privacy and security settings in the center that you saw in the video, and then LED pattern. The way object recognition works on the device, without getting too detailed, it is a cloud-based process, and there's kind of the notion of object recognition, which is the ability to actually turn on and detect objects, but then there's object data, which is the ability for an app to access the object data that you've already tracked. So those are kind of two different things. So the experience that I showed you before, where when you go into settings and you're turning this on, it's pure demo. It's not like a practical application. It exists for really two reasons. One, to show you as a user developer how object recognition works, and get you excited about that. And two, really for transparency, just to show you, okay, here's what objects are detected, here's how confident the system is, and so forth. So it kind of serves to that twofold function. But the idea is that third-party developers would also utilize object recognition as well, which I'll get into. So when you first go into a space, a dialogue comes up and asks you to look around the room for these different objects. And a part of the reason we do that is because there's a little time in which we have to send data up to a secure cloud and get data back. So it's not immediate, but hopefully in the time you've read this dialogue, you start to see objects, and we'll show you a virtual one on the right, like kind of floating there to let you know what it looks like. And then once the objects start to come out, they start popping around, popping out, and their labels rotate, and it's pretty cool to see in person. And then here are some screenshots of some of the objects in my living room and office. In terms of like a third-party app having access, I'm pretty proud of the implementation that we came up with here. I think there's a lot of great patterns of consent and so forth in the UI. Here's an example that I'll show you, and it's nothing confidential. This app doesn't actually exist, even though it's a brilliant idea for an app. But so in this example, the app called For Nature uses object recognition to transform your furniture into the great outdoors. So basically what it wants to do is look at your couches and chairs and tables and cover them with virtual moss or desert, or and so forth. So you're going to either deny or grant access to that app. And most likely you'd have this app open. You'd have to open this app, and it will ask for user consent here, and then it can do what it wants with the data, and hopefully do good by it. I'll talk a little bit about another aspect I worked on, the Capture app. This is how you capture photos and videos on the device. It's also a way of streaming, specifically streaming to Twitch. And so this is another area that's privacy heavy for sure. When you take a photo, it's going to an app called Gallery. The Capture app, basically there's a unique combinations of buttons you press under control once you kind of figure out what these are, it's pretty memorable. And then when you do that, it pulls up something called a capture picker. It allows you to take a photo, a video, or stream to Twitch. It streams the actual video feed from your front-facing camera with the augmented content overlaid on top of it. So this has great practical applications if you see like a funny bug or something that you want to document while you're developing stuff. Even if you're developing in Unity, this will work. This app will run on a system UI layer on top of a Unity or an Unreal app, and you can document it, and also document for the purpose of like promotion and showing things on Twitter. It's how I made the video I was actually showing you before.
Yeah. So Chris, you had a comment in the chat. I don't think people on the video won't be able to see your chat comment. If you can say it out loud.
Oh, sure. Yeah, I was just, there was a question about using it in Unreal, but since, you know, the found objects or object recognition API is exposed through the Lumen SDK C API. In Unreal, it's C++ based, so you can pretty much access any of the Lumen SDK directly. So even if the components haven't been exposed through Unreal yet to make it kind of easy to use, you should be able to access the found objects API through the ML found objects.h header inside of the Lumen SDK.
Chris, I'm really glad to have you on the call, man. Thanks.
Yeah, no problem.
So let's go into like a specific capture feature. This is the stream to Twitch feature. This is an especially sensitive feature because whereas before you're taking a picture and potentially uploading it to the cloud if you choose to go that route and have a mobile companion app for the Magic Leap on the phone, or maybe even from the gallery you're going to upload content to YouTube. So, but the point is, if you take video or photo through these other ways, it's usually an additional step before it winds up somewhere. With Twitch, you're basically, I think we know how Twitch, most folks will know how Twitch works on here, but basically it's like basically live streaming to the world. So once you turn Twitch on, their users will see everything that you see. And so for this feature, you basically get to it with the capture picker by launching the capture app. You choose Twitch as a countdown, and then we try to come up with a very, very lightweight UI here. We want to let users know they're streaming. We want to let them know how to stop. And then the security indicator in the top left is basically what we're required to let the user know that they're being captured. And this icon is to describe that we're basically we're streaming what's on the screen. And so it shows up in the top left of the field of view. And then when Twitch stops, you have a series of dialogues and so forth that'll render. So that's a pretty lightweight app. Let's talk about the LED patterns. So this was when Feras and I first talked, we had a pretty interesting discussion about the function of the LED. So on the Magic Leap 1 headset, there's actually two LEDs. There's an IR LED, which you can see in the screen capture in the bottom left, kind of blinking really, really rapidly in the middle of the device. And that's actually that's used for spatial stuff, for spatial camera. But there's then a more visible LED off to the right-hand side. And that is used for functions linked to surveillance and capture. And so there's a lot of challenges here. First of all, you're working with a single LED. You can leverage color and you can leverage motion to convey a pattern. And hopefully the user's body language coupled with this pattern might provide some kind of indicator as to what's going on. For instance, if they're in an app where they're talking and using the mic, the LED will like kind of pulse blue. So if you saw them speak and you saw the LED do that, the hope is that you would kind of put two and two together. Another convention we're leaning on is the red LED pattern. And it's on this like thin line between Terminator and 80s camcorder. Both that glowing red pattern is associated with both of these things. So we use it to indicate recording. Yeah, it's interesting. But for the most part, the other patterns, most people don't know what they mean. So when you ask someone like, what is a slow, irregular orange pattern, they don't know what that means. So what we need to do is provide training, provide indication, which we do on the website, for what these patterns actually mean. And you'll notice the three major capture patterns also have really different cadences. So if someone were colorblind or low vision, or just looking at the LED from a distance, they would be able to distinguish what they mean. I don't know if Frost, did you want to add anything about?
Yeah. No. So I think here, because a couple things that, and this is one of the first things, A, that Tim and I talked about, and B, that I was really interested in diving into on the privacy side of the device. So, you have a device that has about, as many sensors as a Tesla, for example, in terms of radar detection and some of the camera technology, but it's as ubiquitous as a phone, right? That's like the promise of these devices. And so, we're bringing it into sensitive areas, like our houses, and even in specific areas of our houses that very few people get to see. And this promise is that, by uploading the data and also in public spaces, right? But yeah, by uploading the data, you'll be able to enjoy all these benefits. And so, one of the questions that you might ask is, okay, well, what do you give up and what do you have to do to get that benefit? And so obviously here you're sharing all this information with somebody, right? So in this case, Magic Leap magically takes all this information and process it as Tim was talking about, by doing all these mapping technologies, mapping processes, and then it returns to you really useful information, or hopefully useful information to you about where things are, so you can orient them both as a developer but also as a potential end user. So the thing here to think about is there's a really well-established concept in privacy around transparency, right? And so one of the things you'll notice is that obviously we're trying to collect data as transparently and with as much accountability as possible. So again, you can take your own laptops and your own devices, for example. Right? Like my laptop, for example, we're on Zoom right now and it's recording, and meaning that the camera's on and there's a green indicator above my next to my camera, right? So the idea there is that I'm supposed to know that the camera's on, it's recording. To Tim's point, that's one pattern among several patterns that we can rely on, right? So again, going back to the 80s, even in like the old newsrooms of having a red indicator on air or recording, or you're on notice, right? Those red lights is something that we associate. But again, I think one of the questions that you have to legitimately ask is what pattern is going to work well in this new world. So Magic Leap made an attempt with this magenta color in the middle, and then maybe specifically breaking down things. But if you were to walk in with the pair of glasses and the orange indicator light is on, someone might say, hey, your battery's low. They wouldn't really understand that, what's happening is there's object recognition happening. There is, all this sort of room mapping is happening. And so one of the questions here is, how do you continue to be transparent in an environment where people really don't understand the patterns yet, right? We're still learning. So this is really important, because part of the privacy, sort of ethics is giving notice, right? Being transparent about how you're collecting data, what you're using it for. This is hard to do in public spaces, but it's obviously a little bit easier to do in places with an interface, right? So here, when Zoom is recording information, Praveen, you told us, hey, you're going to record. We have an ability to opt out. There's an ability to say, hey, I don't want this to be recorded. I don't want this to go to the cloud. I don't want this to go on YouTube. So where will that opportunity come from when we're in a world where these devices are always on? I'm walking into the store with them. You're walking into my house with them. We saw some really nice photos of Tim's house, but what else is Tim going to share, maybe inadvertently, that he didn't mean to, and who's he going to share it with? So these LED patterns are really important because they're the beginning of a pattern of understanding between the device, the manufacturer, the developer, obviously, right? In this case, you guys, and the user, right? And so this is something that is not a solved problem by any means. And we'll talk through later on different ways that other companies in the space are handling this. But I think this was something I was initially interested in Magic Leap, and some of my early work was kind of looking into this issue of how do you provide notice, how do you how are you more transparent, right? In this world of even more ubiquitous, even more data capture, right? So like you could argue that when I go and I turn my phone on, like just having my phone on and just going like this, I'm walking around a store or walking around this public space, people might know that I'm recording, right? But when I have a pair of glasses that's about as, as stylish as the pair of glasses that I'm wearing now, it will be as obvious to people that I'm always recording, or that everything I see is going to go to the cloud. Everyone, even if they didn't want to be in my video, will be in the video. So there's a lot of unpacking we have to do here with consent and notice, right? Those like two concepts of transparency, and maybe those things will break down. Maybe they're just not reliable anymore, and we need to come up with new solutions.
So Marie had a question
Sure.
for us. Marie, do you want to ask it on air? Because people on the video won't be able to see the chat.
Oh, okay, sure. No, I was just wondering about, you're talking about the privacy of it. So once you do, like you said, you're showing your house or your room or something, like, is the Magic Leap device uploading that and saving it somewhere? And then is that then connected and identified with you as your user?
Yeah, that's a good question. And out of respect to the Magic Leap folks, I won't comment specifically on what they're doing now. I'll just kind of comment generally on how this would work. And it might apply to Magic Leap as it exists now. It might apply to others. But generally what happens is that, the data is captured. And Chris can also correct me, and Tim can also correct me. But there's two ways of processing on the device, right? There's this computer that sits at your belt, at your waist, and then there's this computer at the top. And so a lot of the technology is designed in a way that some of the data doesn't have to leave, right, the system. It can all be processed on board, meaning it might not leave the device. Sometimes the data has to go. Some of it maybe is just small pieces. Some of it's maybe de-identified. Some of it's just numbers. It's not really actual objects, not images. And so I think the question that you're asking is, okay, well, the images that I'm capturing with these devices, where are they going? You could imagine one of three things. One is it could go no further than the system, meaning it doesn't leave the device, right? When you think about some of your phones, like, you could have local storage, right? That concept of local storage, that could be an option. Another option is that maybe some of it does go get processed in the cloud, right? You send a little bit of it to the cloud, it gets processed and it comes back right away. And then the third option is all of it goes in the cloud, all of it's stored in the cloud. And then when it's stored, how is it stored, right? Those are serious questions that we all can be asking. Is it stored in the raw form? So like, what you see in my house is exactly what maybe someone at Magic Leap might see, or someone at Apple might see, or someone, again, in one of your companies, right? Is that what you're going to see? Or is it the case that what you're seeing is just a geometric representation of my house? So you're just seeing the points. You're not really seeing the semantics. You're not seeing the context behind it. You're just seeing the mesh or the points behind it, right? Or you're seeing maybe even less than that. Maybe you're just seeing like, hey, there was a room, and in that room there was 4 or 5 things. So it depends on a few of those factors. I'm not going to comment necessarily on what's better or worse, because it depends. Obviously, I think my position as someone who's an advocate for privacy is that we should be taking the most privacy conscious approach, especially when we're talking about recording sensitive areas like someone's house. But yeah, I mean, I hope that answers your question, Marie. There's kind of a spectrum. I mean, it's not that different than, kind of the way that things are captured today on our mobile devices, but it obviously is a lot different in the sense that there's a lot more data, and it's 3-dimensional, 4-dimensional, rather than just like a picture. You know what I mean? I hope that answers your question, Marie.
Yeah, thank you.
Yeah, so when you are going into settings, you have the option with a lot of these different things like world features and world models, having them stored on device. So that's local to you, going nowhere. Then there's this label called I think it's personal, and that's for you, but stored on the cloud. So obviously hosted somewhere. And then there's another third option called shared. And in the most recent soft update, that those are the different tiers, and shared is basically at that point, it's basically out there for other Magic Leap users to encounter. Of course, if it's an object detected in your house, they're not going to be able to get into your house to see the object in the first place. But if you're like out in a public space, yes, you have shared features on, and you've enabled object recognition, and you walk up to a bench and it recognizes it as a couch. You know, then Feras walks over, he'll see that it's also labeled couch. But in the beginning, that set of objects is really is simple and almost mundane. It's not enough. It's not quite like a crime scene. I mean, there's no ability to detect a gun. There's no ability to detect people's faces. It's furniture largely initially, yeah. So hopefully that answers your questions there.
And maybe another thing to kind of add, if you don't mind, is that like currently we're not using like GPS location data to localize to a map, right? It requires the device to physically see the space and see similar features in that environment to identify the map that the data is coming from. So, I mean, even like if you were to scan the inside of your house and save your map publicly, if somebody was, say, outside of your house with Magic Leap, they probably wouldn't localize to the same map data just because they're not going to see the same set of walls and the same features that you did while you were in the house. You can think of the map that's created of the inside of your house kind of like a shell around you, whereas if you were outside of the house, it would be like a physical object sitting there because you're scanning the outside of the walls instead of the inside.
Yep. Yeah. Thank you for that. Yeah. So this slide, I think, is even more relevant knowing that we have a lot more healthcare focused folks and training folks on the call. But yeah, I mean, and I'm also remiss if I didn't mention that Bill Curtis Davison and I were on the same team. So Bill and I worked on the healthcare team, but we sat together sort of in a regulatory function. So Bill and I worked very closely on a few projects, including one that was, a major partner of Magic Leap's in the surgical space. Particularly was interested in doing pre-surgical planning, pre-surgical navigation planning, and training for surgeons, right? And so, again, the problem space here is that surgical planning is really difficult to do. It's expensive and it's limiting, right? And so, what we were working on was a couple of different programs, right? One, this is an image from a partner called BrainLab. BrainLab is a German-based MRI and medical imaging visualization company, and so this is a rendered example of an experience that they produced that we helped them with. And here it's about visualizing anatomy, right? And so when you take a brain, for example, there's all these different pieces of the brain, which everyone here obviously knows is very complicated. But what surgeons want to do is they want to walk a patient through and say, hey, this is really the area that we're going to think about is this, right? And you kind of liken it to flight simulation. And this is how it's been described by many folks. You kind of want to be able to zoom in, zoom out, show them the path you're going to take. And so when we think about this and we think about it in the consumer space, we think about it in the sort of everyday life space, there's a couple of things you think about. Again, you're going back to like, where is the data coming from? How do 4 people all visually see my health information? Let's assume that this brain is my brain and I'm the person in the middle. It's not a trivial thing to think about how I share my health information with somebody else. It's actually pretty hard when you think about it. And so when, for folks in the healthcare space in particular, know that there's a lot of regulation. There's a lot of rules, and there's also a lot of data formats you have to figure out in order to make this sort of experience, assuming it's actual patient genetic anatomy, possible. But here, I think going back to the point that Tim was making earlier, is that a lot of this relies on a shared understanding. It relies on folks understanding the patterns and being in the same space. and then being able to participate in a really cool, unique experience, and hopefully that drives value. So I think here the thing I would emphasize is, again, like the sensitivity of the way the glasses can be used, right? If you're bringing them into the surgical operating room, if you're bringing them into a patient's bedroom, if you're bringing them into, your house, and it's, your brain that's being on display. I think it's important to ask these questions about, where does the data come from? Where is it living? Some of the standard questions we ask about other types of technologies, including our phones and laptops and sort of internet, sort of software-based, cloud-based hosting. But I think it's all the more important now because, it was actually a lot harder for me to share my medical information with my phone. We just had to physically pass it around. Maybe it's hard to just drop a link and everyone can see what I'm looking at here. We can argue it might be easier, right? We all have the glasses on and I can just put something up and everyone can see it in 3D. So, I think this is something that, we worked on extensively. It's a live project. You can look up Brain Lab, you can look up the partnership, and there's a lot of really interesting things going on there. But here, the point I wanted to add is that, we are certainly talking about the consumer space, but even in the consumer space, there's a lot of applications in health and education that have sensitive types of data that we'll need to be more mindful of as a industry, not just as a company at Magic Leap, but the entire industry needs to be more mindful of this.
Thanks for us. So before I go to the kind of the next slide and then on to the next section, it's helpful to mention that up until pretty recently, Magic Leap as a company had a dual focus on both enterprise and consumer. And I think what's kind of interesting about the enterprise play is that, of course, security is of great concern, but because this is an occupational role for MR and not a social media role, the kind of data and kind of information you share is vocational rather than personal. And that's not to say that there are exceptions, but it's just kind of helpful to note going forward, because in the next section, I think we'll talk more about social media applications and XR. So with that, we're going to enter the part 2 of the talk. To understand the future of XR wearables and social media app usage, it's helpful to look at an existing application like Instagram. So on my mobile device, I have hardware settings, which I'm able to, where I can turn on my mic, turn it off, control, like share location, one time, never, etc. And even though I have a lot of control here, and even though this iPhone is quite secure, once I put data into an app, there's a lot that I'm sharing that the system has no control of. And for example, like with Instagram, I shut off my mic and my camera, so I'm not going to use the stories feature. But that doesn't stop me from uploading photographs, providing text, labels, and so forth. Even if I'm not sharing my location, I can type my location, and there's a whole bunch of data that I'm sharing. And with that, there's inferences, right, about that data. There's object recognition. There's looking across your peer network and so forth, face detection, exploring relationships. The point being that the privacy funnel has expanded, or rather contracted, as that data funnel has expanded. And yeah, the reason why that's interesting in light of this talk is because that funnel will only grow with at the advent of mixed reality and XR and the kinds of tech that's coming down the line. What's interesting to do, I mean, using the phone as like like an example, kind of an entry point, which is it is an XR device in itself, is to kind of look at some of these patterns, these UI patterns that control that funnel already. So an example, like on the left, Snapchat is unusable without camera access. If you try to open it and you haven't gone over and turned on your camera on the left here, where Instagram lets you like not use your camera, Snapchat's asking you. And in a way that's really kind of admirable, because it's basically saying, you know, we're a camera app. You need to turn your app on. So I think in that I understand, as far as I'm concerned, that's a pretty good design pattern. Instagram, to their credit, has a new pattern that says you're all caught up when you're viewing older posts, which is nice. It makes you feel like you've done enough searching. But perhaps once you encounter this, that's a time when they provide you with more content. So there's kind of like that one is like a double-edged sword, really. And then the one on the right is a recent favorite of mine is on Instagram, where if you deleted your Facebook account years ago, which I have, now a bunch of Facebook users can come back and connect with you over Instagram. So this idea of taking these networks, these disparate networks, and allowing them to connect to kind of gather more data and more connections for these platforms is compelling. So let's talk about some consumer MR, VR social apps. So these are like examples of early metaverse worlds, I would say. Actually, the only one I'm showing here is Horizon, because it's just such a good example of a virtual world that is the business model is basically it's free, but you're paying with your data. You're basically giving, eventually you'll be giving information to advertisers. Facebook will monetize off of this. It's helpful to look at hardware, VR headsets, and as example, as metaverse data collectors. That's not to say that they can be used in ways that are completely tame and safe. But the same social media apps that are drawing us in on our phones today are will be ported to these devices and run on those devices, and new networks will arise. There's these consumer MR glasses like Snap and Real, Google Glass, which is actually kind of more of an enterprise play. But these are yet another way for companies to running these apps to collect data. And then phone tablets, which are out in the world today as a way of kind of gathering data and adding to these social graphs already. Many of them have powerful sensory wear, like the latest iPhone 12 Pro, built-in LiDAR. So there's a lot coming down the pipe, and that's not to say that it's not necessarily for good, because there can be a lot of good, but users need to be careful with the amount of data that they're sharing. Peripherals like the AirPods, Apple, who's notoriously secure. As soon as you turn on your mic, you're wearing AirPods, you're in an app that's processing your voice. You want to be aware that that app is doing so with your consent, that that data is being used the way you think it is. I mentioned I'm not a Facebook user. I have an Instagram account, not a Facebook account. We do own a Facebook portal, like the one on the bottom right, and that is on my wife's account, actually. And so that's something I kind of grapple with, the fact that we have this great TV camera that sits on top of the TV in a allows us to talk to our family and even frames the kids. It's great when they like start to run off the shot, it auto crops to them. But we're giving lots and lots of hours of footage of our kids to Facebook with this camera. So there are trade-offs here. So just something to think about. And then we have a slew of future MR wearables from Facebook's Project Horizon, ARIA, which they have been super clear about the fact that this is a research effort, even putting the word research on the side of the glasses, which I love. But we have to keep in mind that this is Facebook, and this is the world we live in, right? Social media apps that are essentially free because they're using your data. Neuralink, and then whatever Apple is going to be producing in terms of MR wearable is going to be interesting too. We'll talk a bit about Facebook, what Facebook calls live maps. Example, this on the right for like a local space, like a house, and being able to kind of track objects and so forth within the house or space. Magic Leap has its Magicverse, and this is not a new concept. This is something that we know will need to exist. This idea of like persistent coordinates on a grid. GPS is not resolute enough, so we need better tech to get the kind of precision so that you and I can walk around the world and basically see the same objects from different perspectives and so forth. So this is something that needs to develop, but is developing. Object recognition, I think this is the thing, when you post to Instagram or Facebook or Twitter or any of these services, they won't tell you this, but they are actively tracking objects in these images and processing them in every way they can to understand about your life and those objects. And there's a much larger graph play. Beyond objects, environmental perception, like this is an example of like a LiDAR scan, and basically a LiDAR scanner would allow you to use it, like do like a depth reading on an environment without having to do like a parallaxing technique with multiple cameras. And so you can get a lot from LiDAR data as well in terms of spatial data. Volumetric capture is a term you'll hear. So all of these technologies coming together as advancements are expanding this spatial computing data gathering funnel for good and bad. So from collectors to algorithms to cloud computing to the fabled 5G bandwidth that we'll all have soon, that will allow us to pipe massive amounts of data up and down from the cloud. So in terms of kind of what I mentioned before, social media and surveillance capitalism, basically we need to be on the lookout for applications that monetize off of user data. We particularly have to be careful with younger people encountering the technology and making sure that they have good relationships with technology, that they aren't getting bullied, that their personal images aren't suffering as a result. Something called the attention economy, the idea that you are, these apps are vying for our attention, and they'll continue to do so in XR. So a little bit about corporate policies and practice. So it's interesting what a company like Facebook will come out and claim, at a keynote presentation, but you can take it with a grain of salt. I like the image at the top left here. My favorite is number 4, put people first. It just cracks me up. And the Michael Abrash, who's chief scientist for the ARIA project at Facebook, this quote also cracks me up because privacy and security need to be guaranteed, of course. But it's just hard to imagine that Project ARIA will launch with that guarantee. I don't even really know what it actually is meant by that statement. The bottom left is an example of guidelines and talking about like the bridge between Facebook and Oculus products, which is being updated. People are quite angry. Oculus users are angry that they cannot decouple their Facebook ID with their Oculus account. Facebook has claimed that by linking that to an actual person, it's a safer place. It's a place where you can avoid bullies and kick people out and have them not come back. But it is also yet another data point on the graph, a very solid data point and graph play for Facebook. With the election coming up, it gets really interesting seeing how these companies choose to intervene or not. So Twitter's Jack Dorsey did something really interesting with one of the president's tweets recently, where rather than display it and show how much traffic it had, it was completely flagged, and there was another link in which you could go and view it, but you were warned that the content was questionable. Talk a little bit about designing for privacy. It was really difficult for me to find privacy design stuff in XR and AR because it's so new, which is both exciting and just something to be aware of. We haven't seen a lot of these social apps exist at scale yet to where this is really critical, but it will become critical as Facebook users and other users of these social media apps move on to these platforms. So we have to build in consent. We need to use good patterns, not dark patterns, which I'll get into. This one from Facebook for face recognition is interesting because before you ever try to make changes to the settings, it lets you know all the things that you're going to miss if you don't if you do that, and it's kind of overwhelming to the user. So we call this a dark pattern. That one would be a pattern of obstruction, and dark patterns are interfaces designed carefully to deliberately mislead users to choose a path they didn't want to take. There were a lot of definitions there, but I like this definition the best. So everything from nagging to obstruction to sneaking, interface interference to forced action. The example on the bottom was basically put together by Purdue University. And these apply to your mobile device, but apply to AR as well. I'll let Feras talk a little bit about government intervention and as well as the standards and ownership.
Sure, and I saw some of this was previewed in the chat. So, I mean, I think around the California Consumer Privacy Act. So I think a couple things I'll say here. One is that technology always moves faster than government regulation, but I think the thing that doesn't is principles and ethics. And so for everyone here, for anyone working in the design space or the technical space, I think it's really important that we're all mindful of what the right thing to do is and what the wrong thing to do is, and having a sense and having that conversation, because relying on a regulator to come in and tell you that you're right or wrong is probably too late. As we saw with number of companies, some of the companies that we've mentioned, some of the companies that we haven't. So a couple of things to note. One is that Europe has comprehensive privacy regulations. They call it data protection over in Europe. It's called the GDPR. It's listed on the title slide there. But the U.S. is trying to catch up. California passed a law that's very similar to it. It's gone into effect this year. companies that are doing business in California probably need to comply. And the obligations are pretty strict if you weren't doing those sorts of things before. So if you were doing sort of best practices, then it's probably not that different than what you're doing. But it is something that is being discussed at the national level. It's becoming a state issue for many states that have, why is it that California residents are protected, California consumers are protected, but not Floridians, right? So folks in Florida are asking these questions too. So, companies, designers, executives, I think everyone's paying more attention to privacy because there have been so many scandals. And that's largely how a lot of folks hear about privacy, including the government. And so I think here the goal is to prevent those kinds of issues from happening in the first place. And I think the way you do that is by design. I think that's what Tim and I have been trying to. I think that if we had a point is, good design, ethical design, privacy conscious design is what will prevent really the mishaps that we've seen in the last decade from continuing on in the next decade, especially when technology just gets more and more powerful, ubiquitous. We talked about, different types of networks coming online in the next 5 years. All the stuff that we saw in the last 5 years will just get amplified. Last 10 years just get amplified. So I think the point here to stress in the last minute or two that we have is just that we really all, are going to kind of wait and see how the government responds. But I do think that it's up to all of us to be more informed and educated about these issues. And the kinds of questions you're asking are absolutely the right ones. But I would just ask them everywhere you can because, no one really has it figured out yet, I'd say.
For us, you want to talk about the standards and ownership?
Yeah. So I think going back to how we might do work together and sort of build community, again, I would shout out some of the work, Tim, that you've done along with Bill and sort of the open XR community, building both now XR access. And I'm not sure if you were involved in open XR, but, there's a couple of things. One is that, no individual company has it figured out. So there has to be a community effort, an industry-wide effort, and there has to be some sort of standards, right? When we thought about the way the web was being built, there quickly became a standards body and standards group that said, okay, well, this is how you're going to build a website, right? So that way it made it easy for a developer here in the US to service a website in the UK and vice versa, and then all over the world, right? So I think those kinds of standards don't really exist now. There's a handful of open source stuff, but I think that's going to be one major piece. Obviously, you see it on the radios and sort of like the radio waves, like the sort of signals and sort of 5G, 4G standards. I think we're going to need standards, and I hope those standards include things like privacy and accessibility into the design framework. And then, obviously, there's a lot of community groups that you can get involved in. Again, Tim and Bill can probably point you towards more resources in the accessibility community, because that's an area that I'm very happy to see that they've been working in extensively. But really, I think those are the two big pieces, that standards are going to need to come through, and people on this call will be part of that process. And then again, this is still going to be a community-led effort even in the future. So again, folks in this community will be a part of that as well.
I'm going to end on a positive note that we have these utopian ideals, and I think we can ultimately work towards that. We just have a lot of work to do. In the meantime, there is this ground level reality of what we're facing and what we need to overcome. But I believe we'll get there. Thanks a lot, and thanks for us.